Okie dokie, in this video I'm going to knock out the Unit 2 quiz in preparation for the first exam. In one video, let's knock out these 16 questions. Here we go. The diameter x in inches of a batch of ball bearings is manufactured, satisfies the inequality here. What's the smallest diameter it can have? What's the largest? So from this inequality here, absolute value being less than or equal to something means if we drop the absolute value bars, the stuff inside the absolute value bars, x minus 0.2, will be in between or bounded by negative 0.02 and positive 0.02. That's just what happens. Like if you have absolute value x less than or equal to 1, that means that x has a lower bound of -1 and an upper bound of 1. So we apply that here and we have this. So if we solve for x, we add 0.2 all the way across. Let me do it so it's in line. Add 0.2, add 0.2, add 0.2. When we're doing that, it's almost like we're adding 0.20, I guess. So negative 0.02 plus 0.2 is 0.18, less than or equal to x, less than or equal to 0.22. Smallest is 0.18, largest is 0.22. Let's keep it going. Number 2. Find the values of x that satisfy the inequality. So the first thing would be finding the x values that make these factors equal to 0. So we set each of them equal to 0 and solve for x. We add 6, divide by 3, we get x equals 6 over 3, which is 2. For x plus 2 equals 0, we subtract 2 and get negative 2. So this expression, which I will call y, is equal to 0 at 2 and negative 2. Now we need to test values in between 2 and negative 2, to the left and right of 2 and negative 2. So we know that y, or the expression, is 0 when x is negative 2 or 2. Let's plug in a value to the left, negative 3, a value in between, 0, a value to the right, 3. We're going to plug them in to here and here, wherever we see x, and calculate the overall sign of y, the overall sign of this whole expression. When we plug in negative 3, we get negative 9 minus 6. Negative 9 minus 6 is a negative, but then negative 3 plus 2 is also a negative. So a negative times a negative is a positive. So what this means is not just at negative 3 is the y value positive, but really everything from negative infinity all the way up to negative 2 is positive. Okay? So now we plug in 0. If we plug in 0 for x here and here, we get a negative 6 for the first one and then a 2 for the second one. So it's just positive. So negative times a positive is a negative, which means not just at 0 is the y value negative, but between negative 2 and 2, we have negative values. Plug in 3, we get 3 times 3 minus 6 is positive. 3 plus 2 is positive. Positive times positive is positive. So this means that everything after x equals 2 is positive. We wanted to know, where is this expression, or where's y greater than or equal to 0? And so it's greater than 0 wherever the y value is positive. And it's equal to 0 at negative 2 and 2. So negative infinity to negative 2, bracket, union, bracket, 2 to infinity. Why do we have brackets? We have brackets at negative 2 and 2 because those are the x values that make the whole expression equal to 0. And we want to know not just where is it greater than 0, but also equal to 0. And it's greater than 0, all the values in between negative infinity and negative 2 and 2 to infinity. So this is our solution to that up there. So let's see if we can do number 3 here. Sorry for the bad formatting. Find the slope that passes through the pair of points. y2 minus y1 over x2 minus x1. That's your slope formula. I expect y'all to know that by now. 5/9 is the slope that passes through those 2 points. y2 minus y1 over x2 minus x1. Let's keep it going. Number 4. Find the equation of the line that passes through this point but is parallel to the line passing through those 2 points. So from these 2 points, we need the slope. y2 minus y1 over x2 minus x1. We get 8 over 4, that is 2. The slope between these 2 points is 2. the slope of the line we are trying to come up with, or the line we're trying to find the equation of, should be parallel to the line that passes through these points, which means if the slope between these 2 points was 2, then the slope of our line will also be 2 because our line is parallel. So in this case, m equals 2. M equals 2 is the slope of the line we're trying to come up with that passes through this point, -1, 3. When we have a slope and when we have a point, or an x1 and a y1, if you will, let's use point slope form. Y minus y1 equals m times x minus x1. That would be y minus 3 equals 2 times x minus -1, or just x plus 1. And you can leave it like that if they're just asking for an equation. If they happen to ask for it in slope-intercept form, y equals mx plus b, you could distribute the 2, so you'd have 2x plus 2 plus 3, so that'd be plus 5, so 2x plus 5. So either one of those should do for number 4. Number 5, find the equation of the line passing through those given points. So we have 2 points, so let's find the slope, y2 minus y1 over x2 minus x1. -5 plus 2 is -3. 5 plus 1, 6. -1/2 is just the slope. We need a slope, and we need just 1 point to use point slope form. Y minus y1, so y minus -2, equals m, -1/2, times x minus x1, or -1. If we adjust this, it could be y plus 2 equals -1/2 x plus 1. I'm going to leave it just like that. You can leave it just like that if they're just asking for the equation. If they're looking for y equals mx plus b, you could distribute the -1/2 and subtract the 2. Let's go to number 6. Domain. Domain of the function is the set of all x values that, when plugged into this function, give you a defined function value. There are 2 x values that, when plugged in here, give you an undefined value. They give you an undefined value because they make the denominator equal to 0. So I would say the idea is, when you're finding domains, look for if you have x values in a denominator. In that case, set the denominator equal to 0. We're going to set the denominator equal to 0 so that we can solve for the x values that make the denominator equal to 0, therefore make the function undefined. And those x values will not be in our domain. So if we solve for x, we get not just +2, but also -2. So plus and minus 2. +2 and -2 are the x values that make the denominator equal to 0, therefore are the values that are not in the domain. But every other x value should be valid. So how can we express in interval notation all real numbers except for 2 and -2? The reason I've written x cannot equal 2 and -2 is because this is really our domain. X cannot equal those 2 numbers, but it can equal everything else. So we say -infinity to -2, parenthesis, because x cannot equal it. If we put a bracket, that indicates that it can equal -2. So we do union, another parenthesis, -2 to 2, union 2 to infinity. And that is our domain. If you think about it like this, on a number line, -2 and 2 are the values we want to leave out of the domain. So we can represent that with an open circle, but we do want to include everything in between. So it's like -infinity to -2, parentheses are what leaves out the -2. And then -2 to 2, parentheses, leave out the +2, and then all the way to infinity. Okay? Hope that makes sense. So our domain is just this here. So just this stuff. All right. Number 7. Find the domain. Notice in this case there are no x values in a denominator. However, we have a square root. What values can we not have under a square root? That's right, negative values. So we can't have negatives under square root, so it must be the case that 19x squared plus 16 has to be either greater than or equal to 0. So really what I would say typically is like solve for x and see if you can find any x values. What am I trying to say? Like find the x values that make this equation or inequality true. Now, what you'll find out is that if we start trying to solve for x, we just get 19x squared greater than or equal to -16. In other words, x squared greater than or equal to -16 over 19. And you start just kind of picking this apart and realizing like for what x values is x squared going to be greater than or equal to negative 16 over 19? And you realize once staring at it for a little bit that all x values, when plugged in there, will tell us that x squared is greater than or equal to negative 16 over 19, because squaring x is always going to make it positive. The lowest it could be is 0. So like 0 is still greater than a negative number. So the idea is like there are no x values we could plug in here that would make this stuff negative. So in other words, there's no way to get an undefined function value, which means our domain will not leave out any numbers. It's just going to be all real numbers. Okay? Hope that makes sense. Another way to look at it is just like, again, you'll never get a negative number because once you square it, it's either 0 or positive. Then you multiply by 19. Then you add 16. Like you're doing too much to make it positive, so there's no way it could be negative. All right, let's keep it going. Number 8, evaluate h of 8, where h is g of f. Okay, so h equals g of f, which means we're doing g of f of x. G of f of x means f is the inside function. So if we're finding h of 8, we want to find f of 8 first. You work from the inside out. So f of 8 we find first, and we get whatever that is. So we get the cube root of 8 squared, which is 64, minus 9, so that's 55. So in other words, f of 8 is cube root of 55, so now we want to find g of that. So we'll plug that result into the function g, wherever we see x. So 2 times the cube root of 55 cubed plus 9. The cube root and the cube cancel each other out, so we're really just left with 2 times 55 plus 9. That's 110 plus 9, which is 119. Hope that makes sense. Let's keep it going. Number 9, you can see the answers here, but let's talk about where they come from. So again, f of g is f of g of x. F of g of x would be the function f, but in place of x, we are plugging in g, because g is the input of the function f of x. So you start with f, but you leave a space where x is because you're plugging in the function g. Now, g of f is g of f of x, like that. So we write the function g, but we leave space for x, because in place of x, we are plugging in the function f, which is square root of x plus 5. That was number 9. Here's number 10. Find the break-even point given the cost and the revenue. For break-even point, you can either set cost equal to revenue and solve for x. That's what we'll do here. Another approach would be to just find profit first by doing revenue minus cost, then just set that equal to 0 and solve for x. But it's the same calculation. So either profit equal to 0 or cost equal to revenue. So when we set these equal, we subtract 12x, and we get 8x, and then we divide by 8, and we get 4,000 equals x. So that's just the quantity. That is just the x value. So then the question is, how do we find the corresponding y value? Corresponding y value, what they mean is just what is the cost or what is the revenue? Like what's the dollar amount when the quantity is 4,000? And you can plug it into either equation because we found where cost and revenue were equal. So yeah, it doesn't matter which one you plug it into. So let's say the revenue at 4,000, we get 20 times 4,000. That'd be an 8 for 2 times 4, and then 4 more zeros. So 80,000 would be our output, our y value. So 4,000, comma 80,000. Number 11, manufacturer has a fixed cost, 40,000, and a production cost of 12 per unit. They sell it for 15 per unit. Cost, just for the cost information, would be the fixed cost, or I'll start with the production cost. So the production cost is 12 per unit. So 12 per x, where x is the number of units. So variable cost times quantity, in other words, plus the fixed cost of 40,500. That's our cost function. Revenue function is just price times quantity. the price they're selling for, it's the selling price times quantity. So the price they're selling for is 15, and the quantity would still be X. So revenue is 15X. Profit is revenue minus cost. So 15X minus, in parentheses, 12X plus 40,500. If you want, you can distribute the minus. So you have 15 minus 12X, which is 3X. And then minus 40,500. So that's just our profit that goes here. And then I'm not going to demonstrate this because you can plug things in, but all you have to do for these last two parts is just plug in 12,000 for your number of units there, and then plug in, and just make sure I have that right, yeah. So you just plug in 12,000 for that, and then plug in 15,000 for that, and just calculate those two different profit values. If I remember, I think it was like negative 4,500 and positive 4,500 or something. And I'm just going to take a guess at that. I don't feel like calculating it. All right, I think that was it. All right, so that was number 11. Let's keep it going. We're almost done. Number 12, find the vertex and x-intercepts. Vertex, we always want to start with finding the x value of the vertex by doing negative b over 2a. That would be, in this case, negative b, which is 8. So negative 8 over 2 times a. A is 1. So 2 times 1 is just 2. So we get negative 4 for the x value of the vertex. To get the y value of the vertex, just plug 4 into the function, or negative 4 into the function, sorry. So if we plug in negative 4, we get 16 minus 32 plus 16. We get 0. So negative 4 comma 0 is our vertex. Now x-intercepts. When you think about a graph, and you think about its x-intercepts, the y value is always 0 for x-intercepts, no matter what. So the way to find x-intercepts is to set y equal to 0, or set the function equal to 0 and solve for x. Let's do that right up here. When we set this equal to 0 and try to solve for x, let's factor it. That'll be the best method. Two numbers multiplying to 16 by adding to 8 would be 4 and 4. So really it's just x plus 4 equals 0. So x equals negative 4 for both of them. So really our only x-intercept is negative 4. And again, the y value is always 0 for x-intercept. So it's negative 4 comma 0. So then we look for the graph that has just one x-intercept that is at negative 4 comma 0. And it ends up being this graph here. I don't even have the other options. So just choose the one that is opening upward because it's a positive x squared graph, and the one that has an x-intercept at negative 4. The reason there's only one x-intercept, I might add, is because we have two repeated factors, x plus 4 squared, basically. And so that's what leads to just this like one x-intercept, this like turning around on the x-axis behavior. It just comes down and bounces right back up. Okay? We got a few more here. Number 13, consider the supply equation. Okay? Sketch the supply curve. So the approach here I would take is to find the vertex, just like last time. So x equals negative b over 2a. So that would be negative 14 over 2, or negative 7. So the vertex, or the bottom of the parabola, should occur at negative 7, at x equals negative 7. It looks like this vertex occurs closer to maybe a positive 7, so that's not it. This one looks like it also occurs at positive 7. That's not it. But the looks of these two still leaves a chance for having like a vertex all the way back here at what could be negative 7 on this graph. Does that make sense? Like the x values of negative 7. And same thing with this bottom right graph here. So it's like this could extend down and hit its vertex way to the left at negative 7. So it's either of those. And then let's think y-intercept in this case. For an x-intercept, we set y equal to 0. For a y-intercept, we'll set x equal to 0. In other words, plug in 0 in place of the x's. So p for x equals 0 is equal to 0 plus 0 plus 41. So it's just 41. 41 should be the y-intercept of the correct graph. So that's why this one's our answer, because this graph has a negative y-intercept. And so we can't have that as our answer. So find the vertex, find the y-intercept. That's the approach. Determine the price at which the supplier will make 2,000 units available in the market. So I think that's just plugging in 2,000, but also note that it's supplied in units of 1,000. So I think in this case, x equals 2 represents 2,000 units. So you just plug in 2 in place of x here. So you get 2 squared plus 14 times 2 plus 41, I think. So we'll go 4 plus 28 plus 41. We get 32 plus 41, that's 73. And that's our answer. Okay, that was number 13. Let's keep it going. Management has determined demand and supply are given by these. P is measured in dollars, X is units of 1,000. Find equilibrium. Equilibrium would be where supply is equal to demand in this case. So we set them equal and we solve for X. So let's add X squared. We get 3 over 2X squared, like 1 plus 1/2 is 3 over 2 or 1.5. Let's subtract the 60 and we'll get, I think, 54. Multiply by 2/3 to eliminate the 3/2. 2 times 54, or could we divide by 3? Oh, that'd be 18. So 18 times 2 is 36. So 2/3 of 54 should be 36. 36 equals x squared. Take the square root of both sides. We have plus and minus 6, but in this case, x is, it's a real life quantity, so we're not going to use the -6. We're just going to use the +6. So that would be 6,000 units for this one. Equilibrium price would just be plugging 6 into either equation here and getting an output. And I think it's actually easier to plug it into the second one, just in my opinion, I guess. 60 plus half of 6 squared, which is 36. So in other words, 60 plus 18, which is 78. So that is our equilibrium price. That was 14. Let's keep it rolling. Number 15. Rectangular garden, 64 feet of fencing, x by y. Find the function with the variable x giving the area of the garden. Well, if we didn't have to use just x, we'd say the area is x times y, length times width. But knowing that they have 64 feet of fencing, we should be able to replace this y with something in terms of x. The 64 feet of fencing represents the surrounding fence. In other words, the perimeter of the rectangle. Perimeter is 2x plus 2y, 2 times length plus 2 times the width. And so 2x plus 2y equals 64. Let's solve for y in terms of x. Let's get y by itself. So we can, if you want, we could start by dividing the whole equation by 2. That's just a fun little trick. Or if you wanted to, we could just solve for it normally. So 64 minus 2x, divide everything now by 2, and you get the same thing, 32 minus x. Y is equal to 32 minus x, which means our area can be rewritten as x times 32 minus x, which is our function for the area in terms of x. If you want to, you could distribute the x. You do not have to, though. They ask, what is its domain? So domain is the set of x values that we can plug into this function and have it still make sense in the context of this problem. To make sense means, in this case, to have no negative areas and no areas equal to 0. If we plug in x equals 0, f of x, or the area, would be equal to 0. We don't want the area to be equal to 0. If we plug in x equals 32, we'd have 32 minus 32 right there, which would make the whole area also equal to 0. So these 0 and 32s are off limits. How about the values left and right of 0 and 32? Let's say we plug in x equals -1. Well, that's automatically going to lead to making the x negative, which makes the whole thing a negative area. We don't want that. How about plugging in a value in between? Maybe like a x equals 10. That might be valid because we'll have 10 times 22, and that's just a nice positive area, so that checks out. How about plugging in something greater than 32, maybe like a x equals 33? What's the issue here? Well, x is positive, that's 33, that's fine, but 32 minus 33 would give us a negative when we plugged it in, which means we get a negative area, so 33 is no good either. So this is all just to say everything between 0 and 32 is valid. Everything between 0 and 32 is our domain. We don't use brackets because, again, 0 and 32 gave us a 0 area. We don't want a 0 area. We want some kind of positive area. So we choose values of x just to the right of 0, so like 0.1, 0.001, whatever, and to the left of 32. We can't use 32, but we could use 31.99999. So anyway, this is our domain. This is our set of x values that will satisfy or work in that function. Last one. We have a function, I guess, representing the U.S. public debt from 05 to 2011. So 05 corresponds to t equals 0, and they ask what's the debt in 2005. So really that just means plug in 0 into that function. So that's just f of 0. And you get 8.246, and it's already represented in trillions, I'm assuming. Yep, so measured in trillions of dollars. So this should be our answer to the first one. In 07 means 2 years after 2005. So if time 0 is 2005, then time 1 is 06, time 2 is 2007. So we plug in t equals 2 to this equation, and we get that output. I am not going to do that because you can plug things in on your own. You got that. That's the whole practice quiz or practice unit 2, whatever. Hope this video saves. If you have any questions on any of this, please let me know. Good luck on your test. Bye-bye.